Hey, what's up everyone? Welcome to the stream. Alright, so let's see where we were. So last week we were implementing sound, and we got to the point where we had implemented the square wave generator, which I renamed to the pulse wave generator, I think it is. Let me see here. Try and refresh my memory. PSG, that's right. Tone generator, that's it. Kind of to be in line with the names that are being used in the documentation, which I am trying to find. Let's see here. A little disorganized. Did I close it? I guess I must have closed that browser that I had open. Just give me a second. I'll try to bring it back. Ah, here we go. Make sure I don't show anything I don't need to show. Okay, that's it. So here's a doc that we've been going through. Yeah, that's it. We had stopped here on the mixer. Haven't really done amplitude yet, but that's whereabouts we were. Okay. Oh, you know what? Before I continue, I did want to make a little mention. So there's this Facebook group that I joined a while ago because there's a group basically of like Vectrex fans, and I thought, you know, may as well follow the group and get to know what the Vectrex, what people are doing with Vectrexes today and stuff. And it's been great. You know, I did connect with quite a few people who work on emulators like Malban. I've shown in the past some one guy who tried out my emulator there and was really happy with it. Anyway, so there were a few people who were trying out my emulator. One person said he couldn't run it because he's using 32-bit Windows 7, and so I actually set this up over the weekend so that now if we go to GitHub here. You'll see now that for downloading the latest build, you can download Vectrexy for Windows 64-bit or 32-bit, as well as the Linux build for 64-bit. So this is new. I basically had to set up AppVeyor, and you can even see here there's a build pending because I just did a push earlier. But basically, yeah, this here is now available. So if you're using 32-bit Windows, you should give this one a whirl and let me know if that works. So that's kind of cool. And another piece of feedback I got was somebody actually said, hey, you know, the emulator's not working, I'm getting a blank screen. And that was kind of interesting because I was like, oh, that's weird, I never got that before. When I build it, it always works. But then I did download the version that was built, and sure enough, it was given a black screen. And it turns out, this is kind of scary, really. I debugged it. I debugged the build that comes from AppVeyor, and the bug was over here. Let me see if I can hone in on it. I think it was the projection or the model view matrix. So I have this kind of useless model view matrix, and I should totally delete it. But anyway, oh, just give me a second. Sorry. So yeah, I was saying I should just totally remove it. I just kept it around because of, you know, in case I might ever want to mess around with the model view matrix. I don't see myself really doing it, but whatever. But the original code did not look like this. The original code, in fact, let's see here. Oh, not this one. Here it is. Well, you can see it here. The original code just would assign it a default constructed GLM matrix. And the way it looked like when I looked at the code, and it is the case, is that when you do a default construct, it actually resets it to identity. However, if you look carefully, there's a whole bunch of macros in here, right? Like, if not has GLM has defaulted functions, or if not defined, GLM force no constructor init, which is also checked in here. So there's all these things that say, like, basically it's possible to build GLM in such a way, or use GLM in such a way that you don't get this constructor initialization. And that it looks like, I don't know why, I don't understand why, but it looks like the one from Abwehr was not actually producing this constructor. And I didn't really feel like investigating the why behind it. I don't really care. All I really wanted was to have a identity matrix always. So to do that, you can actually make use of this constructor here that takes a scalar, and it just basically puts the scalar in the diagonal of the matrix. So by initializing it to 1 explicitly like this, you get for sure an identity matrix. And that actually fixed it. After I pushed this change and Abwehr produced a build, no black screen anymore. Because what was happening was when there was all zeros in this matrix, the zeros were being multiplied by this projection matrix, which was producing an all zero matrix. And then all my vertices would be transformed in the shader by this zero matrix, which would bring all vertices to 0. And it would basically look like nothing was rendering. So yeah, that was basically wrong. And in fact, I guess they were all rendering at 000, which I think is in screen space, and so that would be like, I think, the bottom left corner or something. I didn't actually see anything, but yeah. So anyway, that's fixed. But back to sound. So here's PSG, yeah, tone generator. We did all this cool stuff. Started implementing all these instructions. We did the sample. Oh yeah, I did some refactoring, I think, since last stream. I just moved some functions around because it's getting kind of difficult to read. And basically, here we go. So when we call clock on the PSG, which is something that gets called every cycle. So here's the update. For each cycle, we call clocks. We just, one clock. We come in here, we do some state machine stuff. We clocked generators every 16 input clocks. So this is the same as last time. This time we call clock on the tone generators. And then here, this is the code I refactored a little bit. Before I had this big block of code that would do the sampling of each channel and mix them together. Now I call this function sample channels and mix. I keep track of sample sum here and the number of samples. And now the idea is to accumulate this until the moment I need to actually output a discrete sample for our sound card, and then we'll average it. So that's what we're going to try and do tonight. And then this sample channels and mix, that's where I put all the code we had before. I've got a get channel volume here. I have a sample channel. I have this code down here that basically calls sample channel for each one and produces a sample that gets averaged by 6 or divided by 6. This is the mixing part that we were talking about last time. And yeah, we have still a bit more work to do in here, but we'll get there. Yeah, so that basically brings us back to where we were. And that is, let's see if we can get some audio out of the sound card. It's kind of exciting. But before I do that, I'm gonna go get my cup of coffee, which should be ready. So I'll be right back again. Sorry for the sorry for leaving every time, but yeah. Okay. I really need this cup of coffee. I'll be honest, I'm extremely tired. Had a long weekend. A weekend where I had to drive for a good period of time. So just really tired. We'll see how far we get tonight. I'm not sure I'll last that long. Okay, so let's see. Thinking about how I want to do this. There's kind of like two ways I can approach this. So I'm thinking about how, if we look at the way I approach getting the lines to render for let me see here, context. Yeah, so you see how I have this render context, right? Which has basically the lines to draw this frame. It's just a vector of lines, and these are the lines here. And what I do is that I pass this render context into my frame update, and then eventually that gets passed down. If we just kind of follow the breadcrumbs, it gets passed all the way down to the via, and then the via takes the render context, and its job is, and then actually passes it to the screen, just passing it down. And basically, the job of the screen here is to go ahead and effectively add lines to it, add lines into this context. Now, if we go all, whoops, if we go all the way back up here, and we go back to the SDL engine, every frame, when we call this frame update and we fill this up, afterwards we pass this render context down into render scene. And then render scene takes that context and, you know, takes those lines that we pass it and then renders them. So this kind of separates the concerns here. It just says the emulator, its job is just to get back to us this list of lines, which I kind of like. And I'm thinking, maybe I want to do the same thing with audio. What I want to do is really the output from audio, and we see it here, is every frame, if I go to the PSG here, we basically want the sample sum and the number of samples so far. Or like, not so far, but maybe a sum of the samples and how many samples for the number of cycles that we just clocked. So maybe what we'll do is we'll just pass that down into update in a very similar fashion. And then after that, back in SDL engine, after we've called render scene, after we've called frame update, and I get back, say, this audio context, we can then proceed to take that data and do whatever we need to do to like send that to the SDL audio driver at this place in the code, which I kind of like, because because it keeps the whole SDL and audio stuff separate from the emulator core. And I think that's the way to go. But I'm realizing we can't even really do this yet without... oh, can we? Yeah, we can't quite yet. We're missing still a little bit of glue. We're missing the part where the CPU will be able to actually send these commands to the PSG. We haven't actually glued the thing together through the VIA. Like right now, this PSG is completely disconnected. There's nothing that, like there's not a single instance of it in the code. Yeah. In this mode, we're reading the PSG's port A, not the VIA's DAC, so this is probably wrong. Yeah, so this is kind of where we're at. We need to like figure out now how to glue the VIA to the PSG. All right, let's see if we can figure this out. Thinking what's the best approach. There's a few different approaches we can take to figuring this out. Okay. One way is to take a look at the BIOS again here, see if we can make some sense of what's happening. Here, DP points it has D0 ureg pointer to the block of sound data. Basically, they're saying that the format of the block of sound data is register number, music data. Register number, music data until 0xFF is found. It says as long as the register number is greater than or equal to 0, then the music data will be copied. Okay. Dreg, xreg, ureg are thrashed. Okay. Sound bytes. Load x, vex sound shadow, so it's pointed to the shadow memory. And branch to sound bytes x. Get the next pair of bytes into D. Branch if positive, so go back, if not end of list. Okay, and then for each one of these we do sound bytes x, which is here. No, sound bytes x. Wow, that's not confusing. So let's see here, branch to subroutine sound byte x. So there's another subroutine called sound byte x. Here we go. So for each byte we do this. Cause a byte of music be copied. A reg, which of the 15 sound chip registers to modify? B, the byte of sound data. So A and B is address data. X, 15 byte shadow area. Sound byte x only. Okay. Oh, that's if x is called. Okay, because basically in that case we go and we read the value into A, that is an X, because X will have the X will point to the block and we'll have the register value, so we'll point that into A. And then B will be the next one will have data in it, I guess. Let's see. Store A into VIA port A. So store register select byte. Okay, so here we're basically using VIA port A. And be writing to it. port A gets the value this way. So that's the register, and then here's the magic. So sound, oh yes. B direction on, BC on, mux off. Okay, so this is what we need to understand here. I need to refresh my memory a bit here. Into port B. So this is all about how we control things with port B, because we're basically going to be messing with 3 of these bytes. See, if the mux is disabled, we don't do this stuff here. So I guess the else of the mux being on has to do with sound. If mux is on, I guess basically we're going through the integrator logic, and if it's off, we're going to be talking to the PSG. Could that be? Sounds right. So we load 19. So let me go see how that maps here. In hex. So bit 0, mux disabled. Okay, so that's what that's about. And 1, 2, 3. Sound BC1 would be, I guess, on. And B direction, bus direction would be 1. So those are the 2 that have to be sent. So I guess what we do is if the mux is disabled, then we need to be reading those bits and setting them. Something like that. So I call this update integrators, but maybe it's not update integrators we want. Yeah, the reason why I have this function is because we also had this thing where port A is connected directly to the DAC, which in turn is connected to both a mux with 4 outputs and to the x-axis integrator. And we have this thing about even when you write to A, we need to update our integrators. Why was this again? Right, because when we write to A, then one of these values, let's see, is this one here, and this one. You can see A gets read. So I guess it's gonna be the same thing. We're gonna need to do this. So maybe update integrators won't be the name anymore. It'll be something like, I don't know what. Update integrators or PSG or something like that. PSG. Let's go with that for now. If mux is enabled, blah 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 blah. Else. The mux is disabled. We're going to go and read the bdir and bc1. So actually, we're going to want our PSG in here. And like once again, I'm deciding to store the PSG into VIA, even though it technically doesn't make sense. Really, maybe the PSG should be external and then passed in. but it's okay because it's like the screen, you know, it's like driven by the via, so we can think about how we best want to model this later. I still think this is okay. Okay, so here we want to say set BC1, and here we want to do read. What do we want to do? What does read bits with shift do again? Oh yeah, I guess that's what we want. Oh, you just want to know if it's on or not, so maybe just test bits. And we want to be reading what's in port B, or port A actually, is it? No, it's going to be stored into port B. Yeah. So if the mux is off, so it's very similar to up here. And we're going to say port B, sound BC1. And similarly, sound BDIR, like that, sound B direction. BDIR on, BC1 on. Then we do load A1, which turns off the B direction, BC1 off. We store it again into port B. That's going to end up doing the same code. And then of course we're going to need to clock our PSG. So let's go do that in our screen frame update. Let's go clock it where we clock our via here. Should really refactor this code as well. Actually, I could do this on the outside. It's completely independent. Before we mess up our cycles. This is what I don't like about this code, is that I go into this like hack. This is really hacky. Okay, I'm gonna put a to-do here. To-do. Move this code into a clock function. And call it cycles number of times. Okay, so here we update our PSG. Here we do the setting of the BC1 B direction. Store register select byte. Now the other thing is getting this byte to the PSG that we're not doing. Store register select byte. Yeah, it's because we need to also shoot this value there. I think I'm going to do that really, really simply. I'm going to do port A. Always send value in port A to PSG. So I think, does that make sense? It's possible that actually it's upon doing this that the value that's been stored in this port actually makes it to the PSG. Like when you turn off the mux, And maybe that's what feeds the value in. So it's possible that this actually would be more like in here. I'm not sure if we should always send port A value to PSG. PSG's DA. Or just when MUX disabled. There's also the question of when we have to read this, you know? Like, right now I'm just doing the write, but you can also read these values back. See, like here, read sounds chip status. Let me take a look at this here. So store port B. Although this has a question mark, so this may not be valid. So let's see what's happening. So store, okay, store port B, and then after that, load 1 to set these flags. Store that into port B. Then read the sound chip status. So we read back what's on port A. It's probably just to waste a cycle or something, waste some cycles. Because after that, we don't really care about that value, right? In A. We write to port B, we read back from port B. But I suppose if we were to do this correctly, the read, where's the read code? Here, let me split this so I don't lose my place. Read from port B. Oh yeah, it's just some hacky crap here. I think I'm gonna have to rework this at some point. The joystick stuff probably should be coming from the PSG because that's actually how it's wired up. And here when I read from port B, MUX disabled, get value from PSG, and then similar to here, and that's for P, right? Actually, no, not if value is disabled. We just want to set the bits. Let me see. Set bits. Okay, so that just sets flags for port B. That's pretty easy. It's the port A that's kind of annoying. See, here we're saying, if not, yeah, see, this is the kind of code that shouldn't be here. And I'm not checking muxes or anything here. Also, I'm noticing we're checking the data direction register. Which we're not messing around with at all in the other case. What does it say? So if not sound direction. but sound BC1 is on. So I guess what this means is that the B direction, if it's enabled, it means we're writing to the sound card. If it's disabled, it means we're reading from the sound card, which in this case means reading from the inputs from the joystick. But BC1 has to be on for whatever reason. What does this mean again, BC1? Maybe we can figure this out. So BC1 means we're in read mode. Oh, sorry, if B direction is off and BC1 is on, we're reading. Okay. If, on the other hand, if B direction is on and BC1 is off, we're writing. So what are we checking in here? It's like we're checking basically the state of beater off, BC1 on. Beater off, BC1. So we're checking for read mode. Interesting. You know what I'm going to do? I'm going to hold off on implementing the read from the PSG, except for those 2 bits there. But I'm going to hold off because I have a feeling that the code doesn't actually rely on it, and that the only time it reads from the PSG is for joystick. And right now we're kind of doing it in the wrong place, but still it works. We're doing it directly in the VIA because we did joysticks before the sound card, before the PSG. But what we might do is we might move this into the PSG and then we'll do it correctly. So I'm going to put here a little to do to remind myself of this. I'm going to say Vectrex probably only ever reads from PSG to read joystick state. Right now we're doing this. We're reading joystick inputs directly here in the VIA. So for now, we'll skip skip reading. PSG here. Eventually, we should move the joystick reading logic, behind the PSG. Into PSG. Yeah. Okay, so I think what we have now is the glue that we need. Okay, so I stuffed this stuff in Engine Client, which is kind of a shitty place, really. I don't really like it being in here. Probably render context shouldn't be here. Because the screen includes it, Via includes it. It shouldn't be in here. But that's where it is for now, so we'll eventually move it. So we'll put render context, we'll put here, I guess sound context is fine. Or I call it audio context. And what we want sample sum and num samples. Sum of sample values in 0 to 1. Sum of sample values, each sample in 0 to 1. And number of... I wonder if I should just have them be averaged out already. But then I won't. No, it's better this way. I don't know. Yeah. Less error if we do it this way. Collected or produced this frame. Okay, so similarly, we're going to want to pass the audio context here. I'm going to have to like basically tunnel this value all the way down. Let's see if we can do this more intelligently. So we're going to want to do a change to pretty much everywhere we pass the render context, I guess. Let me see. Yeah, not everywhere. Okay, we'll go one at a time. So first we'll start here. Then we'll add this to main. We're going to want to pass it down into the debugger's frame update. Okay. Into Via's update. And then finally, we're going to pass it down into the PSG here. True. Did I put class? True, unreferenced. For now. We'll build our way up. So. Okay, so everything looked like it built. Just make sure it runs. Still running. All right, that's cool. Now, our job here in the PSG will be every frame to go ahead and I guess we'll pass this down into clock. Not done passing it down just yet. Or maybe I can make clock yeah, let's not do this way. Let's do this. Let's move. We can do the sampling after we clock everything. And we don't really need the sample sum anymore in here. What we'll do is we'll do this. Although, oh no, we do want to do it for every clock. Okay, I guess that's okay. I'll do this. Is this correct? No, this is, yeah, I don't know. Technically, do we want to do this every single cycle or just every 16th input clocks? I don't know. I don't know. Let me think. I suppose we do want it every single cycle. Even if it's going to hold a value for 16 cycles, I suppose that's okay. Kind of wasteful, isn't it? I don't know. I'll put a little note here. Do we really? I mean, should we just 16? Not sure. We'll try it after if we get this working. Okay, so back into the SDL engine. So now we need to do our math here. I need to basically figure out what the resampling ratio is going to be. I had to do something like that here. Let me see if I can... What did I do here? How many CPU cycles must elapse before generating a sample? Do I really need to do it this way? I don't know if I have to do it this way. Let me think. What was I doing here? I don't think I should go with CPU samples here, CPU cycles. I should go with time. So we know how many, let's see here. We have a sample rate, which is going to be like Sorry for that pause. To take care of something. Yeah, so thinking a bit about what I've done here, and I'm not sure this is going to work for me. I don't think this is going to work. Let me think a little bit. The Vectrex has a 1.5 megahertz CPU. That gets divided by 16, which isn't actually even, but that's how many PSG cycles per second we'd have. Now if I take that and I divide it by the, let me see here. Basically this here. Now, PSG cycles per second would be equal to this divided by 16, right? Which unfortunately, oh, it's okay. Yeah, 93, oh, that's good. And the PSG cycles per audio sample would be equal to this divided by whatever the audio drivers, whatever sample, that's what I have, right? Yeah. So let's say the sample rate would be, I think it's 100. We're saying that divided by 100. It's not a very nice round number, but so basically, every time we execute 2.12 or so, now obviously we're not going to be able to do this 2.12, but what we'll do is that every third one will produce a sample, and we're going to have to like basically keep the error in a float value so that we eventually correct. I think that might work. So basically about every 2.12 PSG cycles, we must produce an audio sample. Because you can see here that, I mean, I guess we're not producing samples much faster than the actual sample rate. That's what this means, right? we simulate 1.5 megahertz CPU cycles, 93 kilohertz. Yeah. And this is 44.1. No, it makes about, it's roughly twice as fast. So we're resampling like this. I'm just trying to think, what's the right strategy? What's the best strategy for this? Maybe we'll do it this way. Yeah, this has to be a float. I should make this all float. This will complexify this code a little bit, so let's just see how this goes. So I have now available to me this rate at which I must produce samples stored in the audio context. Now I'm going to have to track how many samples so far as a float. And I'm gonna have to keep that sample sum. So we go back to sample sum. So basically what I had before, and num samples. Just do that. Now, if it's greater than or equal to the audio context dot cycles per audio sample, we must produce an audio sample here. So audio context dot samples pushback, and here what we do is we take sample sum divided by the number of. Now, is that correct? Because if it's not a round number, what happens here? What did I do for the NES here? Something similar, right? I guess here it turned out to be relatively close. Actually, yeah. I'm comparing number of samples because it happens to be how many cycles. Yeah, okay. I guess this makes sense. It's a bit confusing because we have two samples here. We have the source sample, the PSG sample, versus the target sample, which is the the one for the audio driver. Anyway, we'll see if this even works. I'm not sure. Alright, so I don't expect this to actually work, but we'll give it a shot. I'm also a bit worried about the effect of playing sound right now on the stream from this emulator. I'm wondering if I should I think what I'm going to do is I'm just going to reduce the effect right now of just make sure this doesn't blow up your ears or anything. So I don't hear anything. Oh yeah, there's no sound yet, it's true. Okay, so I don't see any sound whatsoever being produced yet. So let's see if we're actually getting anything. Oh, we're getting lots of zeros. Okay, well that'll explain the fact that we don't have any audio. Okay, I'll bring this back up. I think it was around here. Let me know if that's too loud. Okay. Now, why are we not producing any sound? This is very difficult to debug. So let's start with the fact that we have a tone generator. I wonder if we ever have a... Might have to switch to debug to get some values here, I don't know. I know initially we have no sound, that's true. That's one thing that sucks a bit about the Vectrex, is that there is no sound for a little while. I think though the title screen here starts to have sound. Like here, dun, 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 if I remember. So let's see. Am I able to set breakpoints in here? No. All this has been optimized. All this has been optimized. Okay, let's disable some optimizations here. I forget if I could do this at file level or class level. not optimized, right? It's the no inline func. I always get this one wrong. Okay, so let's see if we ever get an update duty call. No. Alright, that's interesting. So set period high. So do we not get rights to the tone generators? So this might be in our glue code in the VIA that's not actually working as expected. Comes from the BDIR and BC1. So let's see here. Here is the set, BC1 and B direction, 129. So what we could do to debug this is, if we go back to our bias here, let's put breakpoints on places where we know we're doing the sound bite here. Let's start here at F25B. This is going to be very hard to debug because, let me see, F25B. Okay, so here we are. So we're about to step on a instruction that's going to do a store A into via port A, which really for us, write port A, it's going to write here and it's going to call update integrators. Although this is only doing it for the data direction FF. Oh, that's true. Ah. Well, that's not good. Let's see. Yeah. Data direction. Oh, it is equal to FF. I think this code has been inlined as well. You know what? Let's switch to debug. Should be soon enough that we should be able to debug this. I just realized I'm getting an assertion in my circular buffer. This function doesn't work properly, fix it. That's kind of funny. Oh. That's not good. I remember I wrote this comment because I had refactored this code and there was something wrong with this. Oh yeah, I recall now. Peek back, push back, move front. I just do peeks. Right, I never actually pop. I'm going to implement it in terms of the pop back just for now and see if that's okay. Or maybe I'll do it the other way. Although this is not popping in the right direction, in the right order. I think that's the problem, isn't it? No, I think it's fine. Yeah, I think it's fine. Okay. This is so slow. So we're about to write to port A. There's our value. So this would be selecting a register, store register, select byte. So the value is 10. So we do actually come in here. Is this right? Yeah, and then we look at port B here. So this is just gonna set 0 for these two. Yeah, bits 3 and bits 4. But then it's going to write this guy into DA. Okay. The next instruction, it's going to load 19 into A and then store it. Now that's what I want to see. So value, we have x19. Okay, so now those two are set to be on. Port A still has a value of 10. Now PSG should be updated here. When we update it, let's see what happens here. We're in inactive mode. You see, we should go into read mode. Read mode. At this point, we look at the latched address. Read mode. Oh, maybe I got this wrong. Feeder on, PC1 on. That should not be read mode, right? That should be latch address. I must have got this wrong. See, on should have been latch. Okay, so I have a bug here. 00011011. What did I do wrong here? No, this is not right. Leader and then BC1. Okay. Okay. Still inactive. Okay. So here we write to port B like before, 19. Now here we should see a difference. We were inactive and we are now latch address. There we go. So we set the address here to 10. Perfect. So now that we have that, let's turn these off and see if we get a breakpoint in my tone generator. Aha! Here we go. Duty. So maybe now, you know what, let's go back to release and see what happens. I'm going to lower again the audio just to be safe. Actually, I'm going to stop the music too. Okay. Let me see here. Okay, so still zeros. So we're still getting zeros here. So let's see if we can see when we would ever get a 1. So like, first of all, do we ever make it in here? That would be a good thing to know. I'm gonna guess this gets optimized. Let's see. Yep. Oh yeah, that's one of the problems is I can't say no in line on a lambda. Back to debug. All right, so we do actually get in here. That time doesn't look too good though. I'm going to say we should reset time to what? To duty. I think what's happening is initially the time is 0 and we're doing this minus minus on it. Maybe we shouldn't do it if as long as it is 0. I think I had the same problem here. Yeah, I did. Okay, so it looks a bit cleaner. So now the question is, do we ever get a value of 1 here on a tone generator? Probably not initially because we have no sound. See, now the mixer control is disabled. I have a breakpoint there. Presumably it'll be set to enabled. I didn't even check where that happens. We can go look. Ah, there we go. Enabled. Period, duty, time. Okay, that looks interesting. Okay, so we have a sample that's not actually normalized. Yeah, and that makes sense. Yes, this comes back to my wonky math here. Okay. Yeah, okay. I think I know what I need to do. think this is right. No, I don't think that's right. Yeah, that's not right. Okay, wait, I think I know. I never reset my sample sum. I think that's all it is. I think what I was doing is fine. Maybe. This one here, it's not clear to me if that's what I should be doing. I need to think about that. Anyway, let's see if we get a bit further. So one thing we know for sure, the fact that we got that assert means that we're getting non-zero samples. That's for sure. So that's kind of a good sign. Very small samples, very low rate samples. Okay, so let's see if we hear anything. So not hearing much. Let's see here, or anything. That's too bad. Let's see what's going on here. Now we've got lots of zeros. Why do I have zeros now? Do we ever get a positive sample sum here? It's one of those conditions that's slow to compute. Let's see, how can I... Okay, so we do get some, but very, very, very low values. But I guess that makes sense because we're taking only the tone generators and we're dividing everything by 6, so we're going to get very low values. Try to artificially boost the signal just to see if it makes any difference. Wait a minute. Do I need to? No, I don't need to do anything here. Is my audio callback even getting called? It is. Yeah, there is the question of whether this code is even working. Hello? You know what? No. Let's try something. I even have... I think I'm gonna have to install Audacity if I don't have it. Okay, so we have this huge raw audio file. Let me see, do I have Audacity? No, I don't. Let's try to install Audacity. Just curious if we'll see anything in there. I'm installing it. It's off screen right now. Let's launch it. Looks better than the last time I used it. Right. Oh yeah, import raw. That's what I had to do. And then I have to tell it that it is, I don't remember what, I know that it's, does it end up being 2? I think it does. And I think it's, I don't remember. Let's double check. If we go into, I think it's F32, 2-channel, little endian, I think, 32-bit float. Let's try that. Oh, we have a little something here. Yeah, that doesn't sound like much. But we have something. And then we have a bit more here. Oh, these look like pulses. Oops. I'm going to unmute my output to see if we can hear something here. Okay, that doesn't sound too good, but well, we produced something. Not exactly what we thought it would be, but it's something. I just got to kind of comb over this and try to understand what's happening. One thing we could do maybe to help us. I know that ImGUI has some like graphing features. It might be interesting to map out the sample values over time there and see if it kind of like lines up where I think audio happens in the game. Because we don't have like music all the time or anything. And at least we'll know that we're producing it at the right time, because it's kind of hard to line it up right now. Unless we just... Let me just see. Is it plot lines? Probably. But then I'd have to have like a running buffer, I suppose. Yeah. Okay, maybe instead I'll just write a value in a text box, and we'll just see if it changes to like a value that's non-zero, however brief. I wonder if we'll actually see that. Maybe we could use like a color or something. You know what, let's put back some music. Can't work when it's so quiet. Hopefully that's not too loud. I don't remember what exact values I had before. Okay. Okay, I know what to do. $70,000. So we have like on the order of 70,000 samples here. What if we just rendered that? Maybe it'll be really slow, but we could try. This is probably gonna be bad. Alright, and I can't do it this way, it's true. We'll do it in, because we have to do it before this, and let's see. Okay, so here we have actually oh, look at that. So we're getting a signal here. Oh yeah. It seems that definitely related. Okay, so we don't get anything when we're actually doing gameplay though. Maybe that's because it doesn't use a tone generator. Maybe it's using mainly noise. Let me try a ROM that actually would play more sound. I know we have a lot of sound ROMs. I guess not a good sign. I'm not seeing much here. I don't know. Vectrex. That did not work. okay, it's an absolute size. For Y, if it's 0, then use this label size plus frame padding times 2. Okay, so that's a bit bigger. See, now we see a bit more when there's an actual signal. This just looks like bugs to me. Yeah, it doesn't seem right. I know that in the real game, when this part happens, we should hear sound throughout the whole time, and I'm pretty sure it's using the tone generators for that. So it seems a bit off that it's not actually doing. It's not always playing. This part, it's possible that it's just noise. Another way to do this. Okay. Damn optimizer. Warning. And this. Right. Okay, let's start with volume. Remove the amplitude control from the equation. I don't know. that a bit. Well, it sounds like digital noise to me. Okay. All right, so we've got something. It's definitely not working, but it's a good start. And it's a good place for us to continue in a couple days. I'll think a little bit more about this. We'll have to debug this, try to simplify the situations, and see if we can make some sense of it. But yeah, but I think we're off to a good start here. I think we're getting close. This is really the thing about audio. It can be quite difficult. Unlike graphics, where you can kind of sort of see what's happening, you know, audio is just signals, and it's really easy for it to sound completely wrong, like it is right now. It can be really, there's just so many possible places where there can be mistakes. So we're gonna have to kind of divide and conquer, simplify, and see if we can get something slowly but surely. Oh, it looks like my stream got stuck, probably because of the audio. All right, guys, well, I think that's my cue, so I guess we'll see you next time. All right, maybe if I